Hello everyone, this is Nikhil and welcome back to our channel Nikhil's Learning World. Hope you are doing well and doing practicing on previous sessions. Friends, we will learn today recursion function in Kotlin. Okay, so before start, if you like this series, please do like and please comment if you have any suggestions or any queries, you can comment me. And if you not click the bell notification, so please click on the bell notification so you will get the upcoming session notification on the Kotlin programming series. Okay, and please do subscribe and please share with your friends who want to learn Kotlin programming. Okay, so this is our episode number 18, and today we will dive into one of the most and important concept in programming, that is a recursion in Kotlin. If you ever struggle with the recursion, don't worry, by the end of the video you will understand it clearly. Okay, so what exactly is a recursion? A recursion is a function call itself to solve the problem. That's it. Simple way, a recursion means was a function calling itself. It's called as a recursion. Instead of solving a big problem directly, we break into the smaller piece, solve each piece and combine the result. Okay, there are two important parts of recursion: base case and a receive call. Where the base case where the function stop, and recursion call where the function call itself. Without a base case, your program will run forever and crash. Okay, so keep in mind that's very important. So we can see your example as well. And third one is a problem reduction. So it's an easy step to reduce complexity. Fourth one is call stack. So every recursion call uses memory and many calls and stack overflows. Okay, so that important points regarding the key components on the recursion. The next part is the basic syntax. So you can see here, if for example, like on function name, whatever the parameters, data types, return types, if the condition and condition based value, and return as a function name and modified parameter. So what happened here in the else part, the recursion is happening because the function calling itself. Okay, so if condition in base class is executed, return base value, in else part function calling itself until the if condition is not executed, it will calling itself, right? Hope you understand this problem. So friends, there are two types of recursion: a direct recursion and indirect recursion. So function call itself directly, that's it, that is nothing but direct recursion. And indirectly means what? A function A calling B and B calling A. That is, you understand, the two different functions, one function calling B and B calling A. So that is indirect function. By using the key you can understand. Okay, so we will see in next tail recursion. So tail recursion also important. So what is tail recursion? So when recursion call it at the last operation in the function, that is a tail recursion. So tail means what? At the end recursion we want, at that time tail recursion will happen. Okay, or we can use that. So tail recursion function name. Here tail recursion, it's a keyword. By using this we can define that is a tail recursion function. So you can see here for an example, tail recursion function factorial. You can see in the factorial we have to call function again and again, same function again and again. Okay, so that time this type of function recursion is very important, or you can say helpful, right? So return n equal to 0, and in the else part number -1 and number into whatever the passing parameter number. So Kotlin, what happened? The Kotlin converts into the loop and improve performance and avoid stack overflow. That is about a tail recursion in Kotlin. So in example you can see factorial. Okay, so you can, by using the factorial you can achieve this tail recursion and recursion function, right? So think of recursion like a stacking splits, like each call is added to the stack, and once the base case is reached, they start resolving one by one. Okay. Second example, we can say the Fibonacci series. Okay, if you see the program like in the Fibonacci series, what happened, we need to call a recursion. Okay, so at that time you can use the recursion. So now Kotlin has a powerful feature called a tail recursion. If there is recursion call at the last step, we can use the tail recursion, that is tail recursion tail rec. Okay, that is a keyword. So this allows Kotlin to convert recursion into the loop internally and makes it faster and safer. So the advantages of recursion, like a clean and shorter code, useful for a tree, graph, and divide and conquer algorithms. This type of programs we can use by using, and we can achieve the problem by using the recursion function. Okay, so what next is the disadvantages. So as a disadvantages also on the recursion, it's take and high memory usage, slower than loops, and risk of stack overflow. That is the main issue of recursion. So when we can use this recursion, problem can be divided into the smaller sub problems, like in tree, graph type of programs. Okay, backtrack tracking at that time, and avoid when we can avoid this recursion to deeper recursion, nested recursion. At that time it must be and it could be an complicated to resolve that issue, and it may be infinite. Okay, so that's the reason to avoid the recursion. Simple loops can be solved it. Okay, that time we can use that recursion. Okay, so always remember the key points is like define a base case, reduce the problem size, and practice dry runs. So that is all today's session, and hope you like this session today's, and please you can do and practice on recursions like in Fibonacci's, okay, Factorial, that type of programs you can do. In the next episode we will see that is a higher order function and inline function, very important concept for the Android developers who want to, because in Android higher order function and inline functions we will use. So very important, keep practicing on the previous sessions. And if you like this video and you found this helpful, don't forget to like, share, subscribe with your friends, and please do comments if you have any suggestions or you have any queries. Okay, see you in the next video. Happy coding. This is Nikhil and signing off. Thank you.